very good afternoon to Madam and to all the participants from India. A delightful greeting, Madam. I, Mrs. Soma Mitra, Registrar and Secretary at InterScience Research Network, welcome all distinguished chairpersons, speakers, research scholars, and participants to the International Conference on Computational Vision and Robotics. I'm delighted to share that today marks a very significant milestone for InterScience Institute of Management and Technology, Bhubaneswar. With our recent affiliation to Biju Patnaik University of Technology, BPUT, Rourkela, we are happy to host our very first conference under the esteemed banner of BPUT. Today, we are very much fortunate enough to have with us Professor Dr. Maria Virgo. I'm very much happy that Madam had given her time and efforts to this complete conference. Let me now quickly take you to a short tour that what we would be having in our today's session. We will start with the introduction of the guest and speaker, followed by a welcome address about conference and InterScience Research Network by Professor Dr. Shrikant Patnaik, General Chair, ICCVR-2024, followed by a keynote address on vision and multimodal approach for emotion-based human-robot and human-AI interaction by Professor Dr. Maria Virgo, Dean of School of Information and Communication Technologies, University of Paris. Address by Session Chair, Dr. Vishwaranjan Das, and then we would be starting our paper presentation. Let me now introduce Professor Dr. Maria Virgo, Dean of School of Information and Communication Technologies, formally to our audience. Professor Dr. Maria Virgo is a distinguished figure in the field of computer science, serving as the head of the Department of Informatics at the University of Paris, Greece, and directing both the postgraduate program in computer science and software technologies research laboratory. Her editorial leadership extends to being the co-editor in chief of the Springer book series, Learning and Analytics in Intelligent Systems, and Artificial Intelligent Enhanced Software and System Engineer, as a co-founder and co-chair of the IEEE Intelligent Information System and Applications IISA International Conference Series. Dr. Virgo plays a significant role in fostering global academic collaboration. Her academic journey is marked by a PhD in computer science and artificial intelligence from the University of Sussex, a master's degree from University College London, and a first degree in mathematics from the University of Athens. Professor Virgo has made substantial contribution to her field with over 400 publications, numerous editorial roles, and keynote presentation at prestigious conferences. Her research achievements are globally acknowledged, ranking her among the top research achievements and global acknowledgement, ranking her among the top in user modeling and educational software, according to Scopus, Microsoft Academic Research. Her expertise is also with a wide range of interest, including software engineering, human-centered AI, and AI in educational software and tools. I am even very much tempted to say that we have installed an IIMT Bhubaneswar, an award on Professor Dr. Maria Virgo Endowment Award for the Best Girl Student of MCA. Starting from the academic year 2024-25, this award will be conferred upon a girl student in her second year for securing the highest cumulative grade point average in her first year of MCA at IIMT Bhubaneswar. The recipient of this endowment award will be honored with a citation, a certificate, and mentorship from Professor Maria Virbo for career growth and development. We are even honored to have with us Professor Srikant Patnaik, General Chair and Director, IIMT Pune. Let me now take the privilege of introducing him formally to the audience. Professor Dr. Srikant Patnaik is a well-known academician and a director of the InterScience Institute of Management and Technology in Pune, where he served as a professor of information management, recently appointed as a lecturer at the UNESCO Chair in Economic System and Human Rights at the National University of La Plata, Argentina. He continues to expand his international influence. Dr. Patnaik earned his bachelor in engineering from University College of Engineering, Burla, now VSSUT Burla, an MBA from Sambalpur University, and a PhD in engineering from Jadavpur University. With over 30 years of teaching experience at prestigious institutions such as University College of Engineering, Burla, SOA University, he has made significant contribution to the field of information and communication technology. He serves as the editor-in-chief of several esteemed journals, including the International Journal of Information and Communication Technology, International Journal of Computational Vision and Robotics, both published by InterScience. Dr. Patnaik had supervised more than 30 theses and authored 3 textbooks and edited over 100 books. His expertise in computational intelligence and machine learning is recognized globally, earning him awards such as MHRD Fellowship by the Government of India, nominations for Marquis Who's and Who, and International Educator of the Year. Let me now take the privilege of this platform and inform all research scholars that InterScience Research Network is organizing a series of conferences, and all publications were from reputed publication houses like IEEE, ACM, Springer, Elsevier, iOS, SPY, Kluwer Academic, MTPI, Hendawe, and InterScience, etc. This is to inform all paper presenters that in memory of Professor Roman Konchev, the organizing committee of ICCVR-2024 has installed an award in the name of Professor Roman Konchev Best Paper Award for the year 2024. Professor Roman Konchev was associated with ICCVR series from very beginning. He has contributed a lot to the efforts of InterScience Research Network. The winner of the Best Paper Award shall receive a citation and a reimbursement of the registration fee from the paper presentation. I, Mrs. Soma Mitra, Secretary of InterScience Research Network, on behalf of the entire research network, wish all the best to all participants. I please request Professor Dr. Srikant Patnaik, Honorary General Chair for ICCVR, to deliver a welcome address and speak about InterScience Institute of Management and Technology. Sir, please.
Thank you, Soma, for introducing the guest, as well as mentioning about the Best Paper Award. So can you release the
Yes,
your PPT?
Yes.
So let me tell briefly about our institute and the activity we are doing here. After that, we'll start our keynote presentation. Madam Maria Virbo, welcome to this forum. Although we know each other for the last 1 year, but today we are meeting online, and I hope you will be joining soon physically in India. we have with us Professor R.N. Sahu from Center for IT Education and Management Education, Bhubaneswar. We have with us Professor Kabat from IMIT Cuttack and other dignitaries. Our institute, InterScience Institute of Management and Technology, started in the year 2007. And since then, we are doing many activity, and whenever we do activity, it is internationally visible and recognized. We have done more than 100 symposiums, seminar, workshops in the area of IT and management education. All the proceedings are published from renowned publishing houses. Already my colleagues have mentioned about it. And each year also we invite professors from reputed university across the globe. Last year, Professor Jesus Garcia from University of Madrid visited during the month of October. Professor Bijan Sugumaran from Oakland University School of Business visited our campus in April 2023. And Professor Bipul Jain from Victoria University, Wellington, visited our campus for 1 month research exchange program. Our institute publishes each year one annual book, and we call it IIMT Lecture Note on Management. Why management? Because we have started this institute since 2007 in the area of management. And only recently, this year only, we have opened Master in Computer Application, and we have affiliated to the local here, our provincial university, that is Biju Patnaik University of Technology, BPUT Bhubaneswar. And we have our presence in the internet through our YouTube channel. It is known as IIMT Open House. Whenever we invite any professional, any professors, faculty, individual, entrepreneur, or leader, we record their talk or interview, and we upload to this for the benefits of the student of our institute, as well as the student of the in general, to all university and institute. We also have a network known as InterScience Research Network, where more than 100 mentors they have joined, and through them we organize various professional activities. So with respect to this domain, robot cognition and computer vision, since our beginning, we are continuously working in this domain. Our first work, it is in 2007, and this book, Robot Cognition and Navigation, was published from Springer. And it is, although the work was done at my previous institute, that is University College of Engineering, Burla, but by the time this book was released, during that time, the institute was opened, and in the book, it has been mentioned that it is published from IIMT Bhubaneswar. Very next year, in 2008, we started our International Journal of Computational Vision and Robotics, and the first issue came out in 2009. And since then, continuously, we are working in this domain. One group is working in this domain, and each year we do some activity. And initial few years, it was local conferences, and a few papers were recommended to the Journal of International Journal of Computational Vision and Robotics. But the proceedings was not available. For the first time in 2023, we came out with the proceeding of International Conference on Computational Vision and Robotics. And I'm very proud to say that various intellectuals and experts like Professor Judge, Professor Margarita, Professor Roman Konchev, and myself, we published. And in the meanwhile, last to last year, Professor Roman Konchev, by the time the conference was held, he passed away. So it was very unfortunate, and we started with his contribution and his support. So in his memory and in his honor, we have started giving an award to the best paper in the name of Professor Roman Konchev. And the wife of Professor Roman Konchev is Rumiana Kuncheva. She is associated with us, and she helps in many ways in reviewing the paper, and he is a member of in the technical committee. So for these years, they are our intellectuals who occupies the position of honorary chair, Professor Judge, and Professor Margarita is general chair, and Rumen Minorov, he is a general chair, and publication chair is Professor Hakim Benjena from Algeria, and Professor C and Professor Yang Hang Tai from China. They are the program chair and organizing co-chair. And here is Madam Rumiana Koncheva. She is International Advisory Chair, and she helps us in reviewing the paper and giving the best paper award. And Dr. Professor Dhananjay Sadangi, he is my colleague and friend. He is helping us in organizing this conference. And this is all about this conference, all about this series and today's conference. So with this, I welcome Madam Madam Maria to deliver his keynote, and I request all the participants. Today we are very fortunate to have Professor Maria to address us, and we hope that next year we'll be physically meeting either in India or in China or in some other country. With this, I remain, and again I am thanking Professor Maria to accept our invitation to deliver the keynote. With this, I remain. Thank you.
Well, thank you again, Professor Srikanta Patnaik, for the very kind words and the very honoring invitation. I'm very glad to be here. I have been in India, and I do like it very much. It's a very beautiful country with a lot of history and many monuments, and this is something that we share with Greece, that we also have a history, and this makes the countries very friendly, I think. Yeah. So I will share my my screen so yes. that I can start the
yes. Soma, can you share the screen?
Yes, sir. I'm doing that. Yes, madam, you can now start sharing the screen.
Okay. All right. Can you see the slides?
Yes.
Yes, ma'am, it's visible.
Okay. So all right, so my talk is about vision and multimodal approaches for emotion-based human-robot and human AI interaction. This is mainly about how we can use vision and multimodal approaches to give some kind of feelings, either understanding or generating to machines through AI, and particularly in robots. This kind of reasoning will allow robots to have an empathetic role, which is important in many applications. for example, virtual assistants, teaching, healthcare, and many other domains where a computer has to act in a more empathetic way. So there is a whole lot of research about emotion-based computing, which is called affective computing. And here I will, in my talk, I will show what we have done in our software engineering lab at the University of Piraeus. So we have done quite a lot in affective e-learning. This is the software engineering lab, which I am directing, and there is a leader of the area pattern recognition, Professor George Tsirenzis, who also has his own lab, and we're collaborating. And we also have a lot of faculty members and doctoral researchers. The main research interests are in e-learning software, AI in education, user modeling, affective computing, software engineering, knowledge-based software engineering, image analysis, pattern recognition, machine learning, neural networks, intelligent tutoring systems, and many other. And we have a lot of previous work of our group in these areas, with many monographs, edited volumes, completed theses. Like, for example, I will be talking about PhDs that have been completed under my supervision or under the supervision of Professor Tsirenzis, and some of the monographs that are related to this talk, object-oriented user interfaces for personalized mobile learning, visual affect recognition by Ioanna Ourania Stathopoulou and Professor Tsirenzis. And we have had a lot of distinctions. For example, the Microsoft Academic Search tool classifies us, myself and Professor Tsirenzis, in the top 120 authors in this area. We have many citations, and also we have a very good ranking for our university on computer education by Microsoft Academic Search in the top 100 universities. So I will actually talk about affective computing in chatbots and robots, which at the moment they're seen as less emotional, more impersonal, and as lacking in emotional richness. So they're not at the moment dealing with human emotions. So there are many theories, especially cognitive theories, showing that and saying that how people feel may play an important role in their cognition. So how they understand, how they react, how they think, how they reason is usually affected by their emotions. So this area may affect the whole area of human-robot and human-AI interaction. So we need to take this problem into account. We can have adaptive robots and chatbots with emotion-related features, and there are, at the moment, there is a lot of research effort towards this area. There are already some prototypes of adaptive robots and chatbots with emotion. But there is also need for extra research because there are also many challenges in this area. So affective user interfaces, they take into account user features which influence human decision-making and memory. And they also show how people react to several situations. Therefore, there is an increasing interest in the automatic recognition of such features, during human-computer interaction. So this is a big area because people have a great variety of different feelings and emotions. So usually the research is based on the basic emotional states, such as like and dislike, emotions such as fear, anger, happiness, sadness, boredom, and so on. These are considered the basic emotional features, or the basic emotions that can be represented in a computer. And of course, there are several attitudes, such as trust and distrust, the cognitive trust and distrust, and affective trust and distrust, how I trust someone affectively by feeling whether this person is, or this computer is, trustful or not. So in this area, we have two big sub-areas. It's emotion recognition and emotion generation. So on one hand, robots and chatbots would need to recognize emotions from people interacting with them. And on the other hand, they will have to generate emotions, in some way show that they have understood what the person feels, and that they can respond accordingly. So these are two big areas for robots and chatbots to develop, because they are definitely, one needs the other, because in an interaction we make a dialogue. So if a person reacts with emotion to the robot, then the robot has to understand what kind of emotion this was and react accordingly to keep the dialogue going. So as I said, in this area, we have done quite a lot of work on emotion recognition, for example. We need user modeling for emotion recognition. User modeling is the process that is executed by the computer so that the system may produce a representation of user beliefs and possible emotional states. So a user model really provides hypotheses concerning the user. It's not that the user model can actually know for sure what the person is actually feeling or thinking. So it provides hypotheses. And the expression of human emotions is very variable and idiosyncratic. This means that there is a risk for having low percentages of successful emotion recognition from given data, which is something that we want to avoid. We want to have as much accuracy as possible. Now, coming to the actual visual, the visual way of understanding, of recognizing emotions, there are several here distances that are in a person's face that change. For example, if someone is laughing, then perhaps the eyes become shorter because the person probably has open lips and we can see the teeth. But this may also be the case in some other kind of emotion. So although we have emotion recognition through vision, we cannot rely only on this to have accuracy and to have a good content relation. So here is a sensor-based emotion recognition, which is also a very, very big area of research, which is based on brain waves, which can be measured, the breathing pace of somebody, if they breathe smoothly or whether they breathe in a fast way, meaning that they're under stress or some other kind of feeling. The blood pressure, for example, if somebody is very angry, that perhaps we have a blood pressure which is very high. The skin conductivity, the audio noise recognition, the body temperature, the muscle tone, and the heartbeat. Again, the heartbeat can be faster if someone is having stress or is anxious about something. All these are other ways of emotion recognition which can complement the vision part, which is very important as well through the cameras. But there are also other ways that can be based on observation and analysis of human behavior, like, for example, the mouse movements without an obvious intent in a virtual reality space, the number of times, say, for example, a student drops out in an e-learning application. Also, there are theories saying that emotions depend on targets. For example, this gives context. This gives the context of the emotions. For example, we may worry, or we may hope, or we may fear, or we may be disappointed because we are having a target, and these feelings are related to this target. Also, there are emotions depending on approval or disapproval. For example, we may feel pride or shame, or we may feel admiration or despise. So these are also emotions that lead our the way we behave. And of course, there are emotions that depend on how attractive is something to us, resulting to love or hate. For example, we say, I don't like this food, or I like this food, or I don't like this, say, this book, or I like this book. Here, I will talk about the way we have used emotion recognition in a virtual reality game with affective features. We have created a game called VR Engage and another one called Verge, and there is an author, the VR multi-author, for edutainment, and this game performs emotion recognition through some chatbots. We have a dragon Here you can see the dragon. We also have an angel coming up. Here you can see actually the dragon. The dragon is guarding some doors. The game has the players trying to find the book of wisdom, which is hidden, and the book of wisdom is guarded by these dragons. But these dragons are also able to perform emotion recognition if the user is feared or is afraid to go in. The person is challenged. The way that a user can get through the door is by replying to a question given by the dragon, which is related to the syllabus of this game, because as I said, this is an educational game. So if, for example, the user has to learn geography, then the dragon will ask questions about geography. And also performs some emotion recognition, so that and also the angel performs emotion recognition, and there is a companion, which is like an elf, giving advice to the user player about how he feels or she feels. For example, if somebody is feeling very nervous, the system understands, performs emotion recognition, and then the angel gives some advice to the user player, saying, don't feel so nervous. This will not lead to a very good performance. You have to be more calm, or calm down, and try to think about the question in a more reasonable way, without having feelings of fear. So this is the way that we have emotion generation through these chatbots that respond to what has been recognized from the students, what the feelings they have. And so the elf is giving some very friendly advice. The angel is giving an advice like a teacher or a parent or somebody who cares about the student. And here you can see the surroundings of the game. This is in an adventure game through some temples. So here we can see emotion recognition based on a cognitive theory. And in this game, we take into account the goals of the students, which depend on their answering correctly, avoiding mistakes, finishing quickly. There are some prospect irrelevant events, like having fun with the actual game, avoid confusion and learning. And there are also some patterns depending on self-actions, like being a good student and not being a bad student. But also there are other agents' actions, like being assisted, for example, by these agents, which are also chatbots, or not being annoyed. If the student is making errors, which is a result of being hasty, careless, or nervous, she may receive or he may receive the following advice. You are being impatient while you answer. Don't be hasty and think well before you answer. Emotion recognition on observation of many modalities. I will show you here what we have done by combining videos and audio empirical studies like emotion recognition from linguistic data analysis and emotion recognition from paralinguistic data analysis, for example, whether people say something or try to they use some words that denote emotions. For example, they may say "oops," or they may say, "Oh God, what have I done?" Or they may say, "Good, this is very nice." All these bear some kind of emotions, and these are analyzed, and they are combined with emotion recognition from visual facial data analysis. This was collaborative work by Professor Tsichrinzis and myself, and by Ευθύμιος Alepis, Dr. Ευθύμιος Alepis, and Ioanna Ourania Stathopoulou, Dr. Ioanna Ourania Stathopoulou, and we had to combine these evidence from microphones, from cameras, and from keyboards. For example, if somebody is pressing the keys of the keyboard in a speedy way, then perhaps they are having a problem. They're being very nervous. And the one question is how one can fuse all these together, and there are several approaches. We have used neural networks, and we also have used decision-making theories in order to understand the basic states of emotions like happiness, sadness, surprise, anger, disgust, and the emotionless state, which we refer to as neutral. If somebody is not actually feeling any of these emotions. And here is how we have fused the modalities. So there are combinations of the two modes, keyboard and audiolingual modality, and also a combination with what people say. For example, they say certain word, they say an exclamation, and what these are and how they are related to the emotions. This is an example. For example, a negative feeling. 8% of the users said something bad, or they said nothing. 26% said nothing. 44% said something, and 22% said an exclamation. As you see from this pie, if somebody is not saying anything, then this modality cannot offer so much in the recognition of emotions, and we have to go to another modality to get this evidence that we need. And here also there are some categories of users. For example, users which are very young, like age 10 to 18, they tend to say more than users who are older, and they're not so they don't want to express themselves so much. And of course, this is the way that we keep a lot of information, and one screenshots showing how these can be fused through decision-making theory. Now, in terms of visual, we have a lot of problems because there are faces that have many obstacles for the analysis, like someone who's wearing glasses, a baby that doesn't have hair, doesn't have teeth, something is hidden from their face, they wear a hat or they don't wear a hat, or they have some difference in the style. All these are challenges for the accuracy of the emotions that the computer understands. And we have, of course, a lot of emotions that have to be found out. So here we have actually created our own database of images. Like here we have the smile, the sad face, the surprise, the angry, the disgust, bored, and sleepy. All these are used to train the neural networks. And here I can show you how we have used these emotions to make emotion generation. This bear here, this agent which talks, which is a chatbot, performs some emotion generation and gives advice. So there is a rapid popularity in robots and chatbots, which are emotion-based, but there is also a controversy. They have to be tested a lot. Here I show you what in a very recent work, the 2024 paper, that I have authored together with Professor Tsichrinzis. It's a framework for efficiency, pedagogical, and ethical requirements for robots and chatbots to be used in education. It's very important to have a framework, because otherwise, the robots will may produce inaccurate hypotheses. So we need efficiency of AI responses, but we also need efficiency of human-AI interaction. Also, we have psychological requirements. We need to be aligned with psychological theories, not to hurt somebody's feelings. And we have to mitigate psychological risks. And also there are many ethical requirements which are associated with the social welfare and the human control. So efficiency is important, correctness, explainability, validability, and efficiency of responses, or the efficiency of human-AI interaction. So we need psychological goals to be met by robots and chatbots. So we need interdisciplinary research in order to use this kind of technology in people's situations. And we need ethics for trustworthiness, for example, diversity, non-discrimination, fairness, societal and environmental well-being, and accountability. So let me conclude. This talk has shown several applications of multimodal affective computing, which have been used in the context of e-learning in our lab. One of the main problems of multimodal affective computing is how we can combine modalities in an efficient way. We use here decision-making theories, cognitive theories, neural networks, and machine learning. And emotion generation is also needed through animated agents and robots. But although they have these robots and chatbots have increasingly popular and advanced in our days, we need to take into account a lot of psychological effects and how we can mitigate risks by maintaining human control and ethics. So this concludes my presentations. Thank you very much for attending. Any questions?